So today, first of all, we'll talk about Java Bean specification. So we got this specification here called as Java Bean. So if any class, if it follows the specification, then we can say that that class is a Java Bean class. If any class, it follows the Java Bean specification, then we can say it is a Java Bean class, and the objects of that class we can say they are Java Beans. Yes. So this is a very simple specification here, you know, which helps us to fully encapsulate an object. Okay, which helps us to fully encapsulate an object. Yes. So I'll explain this specifications and I will give an example on that. If you want, you can just make a running note, make a note of it. You can take running notes. So later on, I'll add a document to the Dropbox folder. Yes. So first of all, for suppose if you want to make any class a Java Bean class, what to do? Okay, let's consider this product class which you got here. As of now, this product class which you got here, this class, it represents products. A product, a product has got an ID, let's say, product name, product description, product price. So these are the fields which have got the product details, let's say, are product ID, product name, description, and price. These are the properties of that product object which we are representing as fields here. So if you want to make this class a Java Bean class, first of all, the first rule here, according to the Java Bean specification, first of all you have to make sure that the class is declared as public. You have to make sure that the class is declared as public. Okay, that is the first rule. According to the specification, a Java Bean class should be public. You can just make a note of it, running notes if you want, you can take it. Next, all the fields which are declared in the class, okay, we call them as properties according to the Java Bean specification. According to the Java Bean specifications, these fields which you're looking at, they're called as fields, properties. And all the properties should be private. All the properties should be declared as private. All the properties should be declared as private. This is a second rule. As per the Java Bean specification, all the fields or properties which you got in the class should be declared as private. Okay. Next, in the Java Bean class, so you should have a public default constructor. There should be a public default constructor. In the Java Bean class, there should be a public default constructor. It is mandatory, must. Okay. Next, you see, now you might be thinking, so if this fields or properties are private, then how can we access these fields or properties? How can we access them? If they are private, they're just visible or accessible within the same class, right? How can we access them outside of the class in that case? So that is where we'll be using the methods. According to the Java Bean specification, for each property we have to declare two public methods. For each property, two public methods should be declared. One method should be a getter method, or it is also called as an accessor method, getter or accessor method. The other one is setter method, or it is called as a mutator method. Yes, getter or accessor method, setter or mutator method. So you should have two methods for each property. There should be two methods for each property. Okay. So that means if I got four properties here or four fields, so altogether how many methods will have?
8.
You'll have altogether 8 methods. For each property, two methods, right? So altogether you'll have 8 methods. What are these getters and setters? The getter method or accessor method is used to read property value, and setter method is used to assign the value to the property. Yes. So getter method or accessor method is used to read the property value. Setter or mutator method is used to assign the value to the property. Yes. Okay. And both should be public. Yes. Hi Deepak. I'm talking about Java Bean specification now. Okay. Java Bean is all about set of rules which a class, if it implements, we call it as a Java Bean class. Okay. And as part of that, this is what I've discussed. The classes should be public always. The field should be private, and there should be a public default constructor, and for each field you should have two methods, public methods, a getter and setter. That is what I have discussed. Okay, fine. So yes. Now let's see how to declare or how to define the getters and setters for each method now. Yes. Let's see how to define the setters and getters for each method. So you see, for that, make sure that it's very easy if you're using Eclipse IDE. So all of you can make a note of it. You know, adding getters and setters using Eclipse IDE. Okay, adding getters and setters using Eclipse IDE. It's pretty simple and straightforward. Okay. So what you need to do is here, make sure that the cursor is in the class. Right click on it. Right click on the class. You see, you'll find source option here. Okay, source. Right click on the cursor. So you should see source option. So under the source, you'll find generate getters and setters. You'll find generate getters and setters. Okay, select them. So once once again I'll show you people. Okay, so adding getters and setters, for that just right click on this class to make sure that the cursor is in the class. Right click on it. You'll find source option. In the source you have generate getters and setters. Generate getters and setters. Select it. Once you select that generate getters and setters, you see a window will pop up. Here it will ask you select getters and setters to create. For which fields, you see, the tool is able to identify the variables which we have declared in the class. You see, now here you can select that fields are variables, for which fields are variables you want to add getters and setters. So I'll select all. Okay, I'll select all and I'll click on select all and click on OK. Just click on OK. That's it. Save this code. Now you can see here we got two methods for each property. So altogether you'll find that we got 8 methods here now. Okay, altogether you'll find that we got 8 methods. Yes. So here we'll examine this methods. You see, the method whose name starts with get, basically they are getter methods. The method whose name starts with get, they are getter methods. So these are all getter methods. Okay, and the method whose name starts with set, they are setter methods or mutator methods. Okay, Yes. So now if you keenly observe this getter methods, you'll find that there is a pattern which is followed here. Okay, there is something common between all the getter methods. So there is a particular pattern which is followed for this. So what is it? You'll find that the getter method name here, it starts with get and followed by the property name. So for which property that getter method is defined, the property name is specified here. Get followed by the property name. Yes. So the property name also, the first letter will be in caps. The property name, the first letter of that property name will be in caps. You see, get ID, get name, N is caps again, N is in uppercase again, D is in uppercase again, get description, get price, P is in uppercase again. Okay. So this is the naming convention which you'll follow. Yes, you have to follow this naming convention. Okay. So getter method name will start with get followed by the property name. So that property name, the first letter of that property name will be in uppercase. Yes. Next, here, you know, the getter methods will not take any value. There won't be any parameters for the getter method. Okay. Always you have to make sure that there are no parameters for the getter methods. Okay. And you see, the return type of this getter method will be same as the property type. No parameters. Next, the return type. So if you keenly observe the return type, you'll find that the return type of the getter method will be same as the property type here. You see, the first method get ID is for ID property. It is integer type. Get name is for name property, which is string type. Get description, it is description for description property, which is string type. Get get price. So this method is for price property. Price is float type. So the return type is float. This way you see always the return type of the getter method will be same as the property type. And basically what exactly the getter method is doing here? Yes. What exactly the getter method is doing here? So it returns the value which is stored in that property. Getter method, what it does, simply it returns the value, see return ID. That means whatever the value which is stored in that property will be returned. The same is the case for other methods. You see get name, return name, get description. It returns the description. So this way you see, so the value which is stored in that property will be returned by this method. That means if you want to read the property value, use getter method. Yes. So is it clear for you people, all of you, what I've explained so far? Any questions? Okay, good. Thank you. So now, similarly, we got setter methods here. So always the setter method name starts with set, followed by the property name again. A similar naming convention is followed for setter methods. Setter method name starts with set followed by the property name. You see, all the setter methods are the same. Set ID, set name, set description, and you have set price. Set price. Next, again you see that property name, it starts with the first letter of the property name is in uppercase. Next, you know, setter method, it takes a property, it takes a parameter. You got a parameter for the setter method, you see. For all the setter methods, there will be exactly one parameter. Yes, there should be only one parameter. And that parameter type will be same as the property type. The parameter type will be same as the property type. Okay. So you see for set ID, the parameter type is integer. For set name, the parameter type is string because name is string type. Description, set description. Again, you see here, the parameter type is string because description property is string type. You got set price. So price is float type. Yes. So next, you see the return type is always void. The return type of the setter method is void. Return type of the setter method is void here. Now what exactly the setter method is doing? Let's see. So can you people tell me what it is doing? What exactly the setter methods are doing here?
It is holding the reference of that variable.
Yeah, it assigns the value. It reassigns the value or to that property. You see, it takes a value through the parameter and assigns it to that field, the instance variable of field, a property. Okay. Yes. Hope everyone got it. So this is what a setter method does. Okay. This is what a setter method does. So is this clear for you people how the setter method works? Why it is used? Any questions? Okay, fine. So this is about the Java Bean specification. Okay. So you see this class, I can say that it is a Java Bean class. So once again, I'll repeat it. Yes. So according to the Java Bean specification, you see a class should be declared as public. The properties of the class should be private, and there should be one public default constructor in the class. Okay, there should be one public default constructor in the class, and for each property in the class, so we should have two public methods. One method is a getter method, and the other one is a setter method. One method should be a getter method, and the other one should be a getter method. Is setter and getters. See, all the properties of this fields, properties of the class should be private. And the getter method, you see, it is used to read the value, and setter method to assign the value, yes, to the properties. Fine. So let's try to make use of this. Okay. Sorry. So first of all, I'll instantiate this product class, and how do I assign the values to that properties which are in that product object now? So you got ID, name, price, and description, right? How do we assign the values to that properties? So you can use setter methods.
Just calling it setter method.
Yes. You see, I'll be calling the setter method. This is set ID. So we got this setter method for that ID property. I'll call it. Similarly, for the other properties also, I'll do the same. Set name. Let's say set price. Set description. So this way we can assign the values to the properties of that Java bean. Now similarly here, if you want to read the values from the bean, from the Java bean, if you want to read the values, you can use getter methods. See product dot get ID, name, price. So for each property we got a getter method, so which we'll use to read that property value. That's it. So let me run this code. Okay, so it works. Now can you people tell me, so what is the advantage of using this Java Bean? Where exactly we use them? What do you people think? When do we use them? Yes. Just a second, please. Just a second. Yeah. Sorry. Just a second.
Sorry, Mahesh. Hello?
Hello.
Yeah.
Now can you people hear me? Oh, okay, fine. Sorry, I thought you people were able to hear me from that time. I was just speaking. That's it. Oh, sorry. Oh, okay. So what I was saying is, you see, I was showing you people this. You see, the properties of this class are private, right? All the properties are private. Yes. Now, though these properties are private, I can say that there is no restriction as such on these properties. How can I say that there is no such restriction on these properties? Because you see, we can read the value which is stored in this property, not only reading it, but we can also assign the values to this properties here. We can also assign the values to these properties. We can do both reading as well as assigning the values. Right? We got full access to that property. We got full access to that property. You got this point? Then why, what is the advantage of declaring that property as private? When we got full access to that property, then what is the advantage of declaring that property as private here? What do you people think? You see, though we have declared this as private, there is no such restriction on that property, right? So you can read the data, you can assign the value. Yes, we can both do both. You got this point? Okay. I can say the main advantage of doing this here, I'll show you people here. For suppose, now we can add just second. Yeah, sorry. So now for suppose here, let's say we didn't declare it as private. Let's say it is public. Let's say just imagine one of the fields is public, let's say. Okay, one of the fields is public. Now if that field is public, that means you can directly access that field. Okay, you can do this and you can assign any value you wish. See, even if I pass a negative value, still it will take it. Actually, the product IDs are not supposed to be negative values. The product IDs are not supposed to be negative values. Let's say, but still it will take any value. So, is there any chance for us to add a restriction? Yes. Can we confine the users from providing negative assigning negative values here? Yes. Yes, you see, is there any chance for us to avoid this or confine the users from assigning negative values here?
By declaring the data type.
No. If the pro- sorry, if the property is public, then it is not possible. If the property is public, it is highly impossible because there is no such restriction on the accessibility or visibility of that property. If I declare it as private, now I have an option. How? You see, directly that property cannot be accessed. You know that, and people can't do this. And if they want to access that property or assign the value to that property, they have to use a setter method for that purpose. This way. So you see, still there is a possibility that they can pass negative values. But you know, this time there is a possibility to avoid these things. How we can add validations. If ID is less than or equal to 0, will not allow the user to assign that value. Okay, we'll print a message, say invalid ID, and we'll just return the control. That's it. We'll return the control this way. You see here, now if that ID value is less than or equal to 0, that means if it is a negative value or if it is 0, then I'll simply print this message. And what this return statement is doing here, it will simply return the control back to the calling method. So if there are any statements, they won't execute now. The control will be returned to the calling method. Now this statement will not execute. Line number 25. So hope you people got it, right? How can you do that? Can you tell me? Okay, if you got any idea, you can tell me. Yes, Karthik.
Well, we can put the same thing as you declared. I mean, we can put the public int ID, and in the test we can directly call the ID. We can put the same. I mean, the same in the private public void set as if
If it is public,
ID.
you
Yes.
see, there won't be any restriction on accessing that field. Directly, you can access that field, and there is every possibility that any type of value can be assigned if it is public.
Yes. Yes.
But if it is private, The only possibility to access that field is through the setter method here. Only through the setter method you can access that field or assign the value to that field. And here we got a chance to add some validation stuff. Okay, you
Okay.
got the point, all of you?
Yeah, I got
Yes. So now you understood why we are adding this setter methods and getter methods. Why we are providing the access to that fields or the data members, I can say, through these methods. Yes. So can I assume that this is clear for you people? Can I have yes or no, please? Okay, cool. Thank you. Yes. So this is the advantage of using the Java Bean specification, you see, because always the access to that fields will be provided through the methods, and in that method there is a chance for us to write some validation code or something like that to add some rules, restrictions and all. Yes. Okay. So this way, you know, we can make this object fully encapsulated here. Okay. Yes. The object is encapsulated now. Yes. Even you can add restrictions on the other methods also, setter methods. Based on your requirement, you'll do that. Yes. Okay. So Java Bean, you see, specification, it helps us to create objects which are fully encapsulated, I can say. That is the advantage of using Java Bean specification. That's it. So now let's move on. That's it. That is what I've got to tell you people regarding the Java Beans. We'll move on. Next thing which I'm going to talk about here is regarding the associations. So as we have discussed initially when I was talking about object-oriented concepts, see it is completely based on objects, right? And its features and all. Object-oriented concepts are completely related to the objects and its features. So here objects have got associations, right? That we need to understand. For example, so far you see we were always working with individual objects or independent objects, I can say. But objects, they won't exist alone or independent. always they will be associated to some other object definitely. For example, if you consider savings account object, these objects, they are associated to whom? You know that. Normally, the savings account objects are associated to whom? You'll have
Juniors.
account holders or account owners, right? A savings account object is basically created for a account owner or account holder, right? Yes, account owner, or you can say account holder. Yes. How shall I say account holder? Yes, anything is fine. Now, how do we represent the association between the savings account object and account holder object? What do you people think? Okay, the thing is here, we are talking about associated objects, right? The first thing is, now the question is, okay, so far we had only a class for savings account objects. But now the account holder is entered into the scene. How will you represent this account holder object in our application first of all? What do you people think? Yes, come on here. How do we represent an object? Account holder is an object. How will you represent it in our application now? What is the first thing we have to do? I'm talking about a real world object. Yes. Yes. Come on here. This is not a very a typical question or a complicated question. It should not take much time for you people to answer this question. Okay, my bad. Unfortunate. So, in order to represent a real world object, here first of all you'll define a class. So I have to start from the beginning again. So we need to define a class, right? And represent the properties of this object. Represent the properties of that object here as fields. Let's say account holder has got a name, say first name, say last name, yes, yes. So the last name, and what else you'll have? Email ID and phone. Phone. Let me add a constructor, a parameterized constructor, let's say here. Fine. So this class now it represents account holder objects, right? Account holder who owns that account, who holds that account, who has an account, savings account, yes. So every savings account belongs to a particular account holder, yes. Now we got these two classes, right? Okay, but I can't say that they're associated as of now. How would you represent, or how will you represent that association between these two objects? That is the question. Okay, so at least you got my question. No one is responding from long time. Hope you got the question right. So how to represent that association between these two objects now, savings account and account holder. In the class, what we are supposed to do in the Java is in this class definitions, how to represent it. Okay, we know that they are associated, but that has to be also, appropriately represented in the class as well. Yes. Okay, so one would have to extend the other. But you see, when do we use extends? Normally for inheritance, for parent-child relationship between the objects. But I don't think there is a parent-child relationship between these two objects. Am I right? Is there a parent-child relationship between the objects? There is no parent-child relationship. Absolutely no parent-child relationship between these two objects. Okay. Even that won't work. Okay. Let me tell you, people. You see, we use references here. Reference to associate two objects. If they are, if there is no parent-child relationship between the objects, in that case, it is better to use reference, object reference. Now, what I'm going to do is here, I'll declare a variable which is of type account holder. You see, I'm declaring a reference variable of type account holder in the savings account class. Yes. Okay. I'll declare account holder variable in the savings account class here. Yes. So that means, yes. So the associated account holder reference, the savings account object is going to hold that reference. The associated account holder object reference, we are going to store it in this reference variable. As of now, we didn't do that. Yes, we're just declaring this reference variable. So when we create savings account object, we can store that object reference in this reference variable here. Okay. Yes. Now this reference variable represents the association between the savings account and account holder. Yes. It represents the association. Yes. Okay. Now let's see how it works here. So I have created a savings account object. Now in the memory, you know what happens. So a block of memory is allocated for that object, and as part of that object, you see the memory for the fields is also allocated, like account number. Just a second. So a block of memory is allocated, and as part of that block of memory, you see the memory for the variables is allocated. And one of the instance variable is holder now. Holder, right? Yes, yes. And the reference to this object is account, stored in that variable account. You see that holder is a reference variable, but it is an instance variable. You know, it is a instance variable here. You see, sorry, not here. Uh, Savings account class. Yes, it's an instance variable or non-static variable. So what is an instance variable? You know, which the variable which is declared in the class. Now the memory for this variable will be allocated as part of that object. Yes, this is just a reference variable. You see, it's not an object. Now this reference variable, we can use it to store account holder object reference. Okay, yeah, just a second. Yeah, I'm sorry. So now we have created the object savings account object. So as part of that object, that reference variable you see here, the memory for that reference variable is allocated as part of that object. Yes. Next, as of now it is null. It won't be referring to any object. Let's do one thing. I'll create a account holder object. Let's see. Or else first let's create account holder object. It doesn't matter. That is for before or after. Account holder equal to new account holder. Let's say name Harry. Harry at the rate mail.com, and the phone number. Yes. Now, when we do this, what happens? An account holder object is created. And as part of that account holder object, you see the memory for the variables is allocated. Like you got first name, last name, mail, phone. Now the reference to this object, the reference of that object is stored in that reference variable, account holder. Yes. So now you see, this is what we did now. So the program, the code which you have written here, so we are creating two objects. Can I say that these two objects are associated? Can I say that these two objects are associated?
Yes.
Yes. How can you say that they are associated?
We have that account holder reference in
As
this
of
one.
now, still I can say that they are not associated. I can say that still they are not associated. Where is the link here? Do you see any link between these two objects? Do you see any link between these two objects here? No. Okay. It doesn't mean that if you declare a account holder variable in the savings account object, if you declare, yeah, you see, if you declare that the savings, we have just declared that variable, right? Savings account, sorry, account holder variable in the savings account class. You see, it doesn't mean that if you declare that account holder variable in the savings account class, now they both are associated. Actually, we have to link them. How to link them? You see, in the savings account object, you got a holder variable. It is of type account holder. In that reference variable account holder, you store this account holder object reference. So now I can say that the savings account object here, it holds the reference to the associated account holder. You see this holder reference variable, to this holder reference variable we have assigned that account holder object reference. That means in the memory now, this holder, now it is referring to this account holder object. It is referring to this account holder object here. Yes. So is it clear for you people? Now I can say that these two objects are associated. They are linked. Yes. So any questions in this regard? Would holder be used? What type of what variable type is holder? You saw that it is actually account holder type. In line number 10, can you see this? That is that reference variable itself here. It associates these two objects now. That is how we represent the association between the objects. You see, in the real world, you'll find that objects are associated, right? They are linked. But that association between the objects which we see in the real world, so how do we represent it here in Java? That is how we represent. How what to do? How it is represented? The reference variables. So the reference variables here, they represent the association between the objects here. Yes. Yes. So we describe it as has a now account holder has a savings account. Yes, has a relationship. Now you see now other associated object details now we can read it through savings account object or reference also now. Through the savings account object reference also we can read the associated object details. Okay. Yes. How? For example, we got account number. Yes. Sorry, not account number. So first name of account holder. Now through the savings account object, how can we read it? You see, in the savings account object, we got you got the holder reference variable which holds that account associated account of account holder object reference, right? So you can do this account dot holder. So this is the property of variable which is declared in the savings account class, and basically it holds the reference to that associated account holder object. It holds a reference to the associated account holder object. Now we can use that reference to read that holder details, first name, you see, similarly last name. See email. So we'll print these details. Yes, you see, through the savings account object, we are accessing the account holder object. Yes, that is the associated object here. So is this clear for you people? Any questions in this regard? Okay, okay, good. So this is one example of the association between the objects. I'll give you people another example here. You know, for suppose, let's say, consider a supplier. Supplier means, so they supply some products, supply some goods, whatever it is. You got the suppliers here. You see, now supplier, let's say, supplies products. Supplier may supply more than one type of product or different types of products, I can say. Supplier may supply different types of products. You see, now supplier, if supplier supplies, let's say, 3 or 4 products, how will you represent the association between the supplier and products? Let's say supplier supplies 4 different products. So a single supplier associated to 4 objects, 4 product objects. So how will you represent that association? So far we saw that in the last example which we saw, in savings account and account holder, savings account object was just associated to one account holder. That's it. But here supplier is associated to multiple products, multiple product objects here. One object associated to many objects. That association, how we're going to represent it here. Yes. So hope you got my question. Okay. But we haven't discussed about collections here. Yes, you are right, absolutely. Supplier has got multiple product objects. Now that is what my question is. How do we represent that here in the code? How will you represent it here in the program, in the code? Here you see already we have a product class here, right? We got the product class, right? Now we all you need to do is just define a supplier class. So let me define it here in this package itself. Let's say supplier. Oops, sorry. No, again it is not an inheritance relationship, right? So supplier, let's say I'll make it a Java Bean class, okay? Supplier will have an ID. Supplier will have a name.
So Mahesh, can we
Okay,
have
these are the
a
two properties in the supplier. And let me just add the constructor in the getters and setters. Okay, this is just a Java Bean now. So one object associated to multiple objects. How will you represent that association? That's a question. The supplier will be associated to many products. I do agree. But when it comes to programming, how it is represented here. So
Mahesh, we can create
you
a
see
getter
in the
setter
programming,
for the product.
as of now, what we can do is we can use an array. We can use an array. So we have created an array, you see here. So that array is what type? It is product type. That means which can hold product objects. We can store product object references in that array. So we can store multiple product object references. It can take multiple product object references here. More than one product object reference, I can say. Yes. Yes. Okay. Now you got it. Next, I'll add a getter and setter method for this property as well. Get products and set products. That's it. Just a minute. Now let me create a supplier object. So we'll add the details. Supplier ID. Supplier name. Some supplier, let's say Tata. Okay. So now we can create product objects. Let me create an array itself directly. Products array. Now let's say I've got three products. So I'll specify the sizes 3 here. Okay. So the array size is 3. Okay. Now we'll add product objects to this array directly with 0th index. Let me add a product object. Now I'll add a parameterized constructor so that I can easily add the data. Later on you can add some constraints also if you want. Just a minute. Say name. Okay. So I got one product object now which is added to that array. Similarly, let me add a couple of products. Say okay, fine. You see what we are trying to do here. Now into that array we have stored 3 product objects. That array now holds a reference to 3 product objects. Now how do I associate this product objects which are in this array to that supplier here? What to do? Yes.
By referring the class.
Just call the setter method and add the array.
Oh, sorry. Is anyone? We can't hear. Sorry. Hello.
Yeah, through the setter method we can add array, the product array.
Yes, you got a setter. You see, in the supplier class, we got a reference variable product which can take that product array reference, and you see, uh, for that product's reference variable, that array reference variable, we got a setter method. Okay. Yes, we can pass that array reference now. So supplier dot set products, pass that array reference. That's it. Now I can say that the supplier object, it holds the reference to the array of product objects. So this is how you see we can associate more than one object associated to multiple objects. For that you can use arrays. Going forward, you will find that we are going to use collections. Okay. So as of now, don't worry about it. Yes. So any questions? Hope you people got it. What we did. Now supplier object holds a reference to the array. In that array, you got all the associated product object references. Yes. So this is about the associations between the objects. Yes. An object can be associated to one other object, or an object can be associated to multiple objects also. You'll find that an object can be associated to multiple objects. Okay, fine. So this is about the associations between the objects. Now you see, uh, now we are able to represent most of the features of the object here, right? As we have discussed in the beginning. Objects, they got properties, behaviors. I mean, we call them as characteristics, So we're able to represent them. Objects have got features like you see inheritance, polymorphism, abstraction, encapsulation, associations. We have represented each and everything here in the code, right? Yes. So now further we'll try to apply this concepts in the programming. Okay. So next I'm going to talk about a very important class called as object class. Object class. There is a class called as object. Okay. Object class. So do you need a break in between? Yes. So shall we take a break? Okay. But I need a break, I'm sorry, because you're just listening. I'm speaking from continuously for a couple of hours. So let's take a break. Okay. Yeah. So we'll take a short break, then 5 minutes. I'll be back in. First of all, I'll talk about object class here. Yes. So is anyone familiar with this object class? Can you people tell me what is this object class?
Object class is a superclass of every class in Java.
Object class is a superclass of every class in Java. Yes.
What-
And so, okay, let's see. Yes, we said object class is the superclass of all the classes in Java. Yes. And you will find that every class, yes, no matter whether it is predefined or user defined, they definitely extend object class, I can say. Okay. For suppose now we got this test class. Can I say that this class extends object class? I can say yes. Test class here, it extends object class. Yeah. You know, when the compiler compiles this code, the compiler, what it does is, it will check whether this class is extending any other class or not. It will check whether this class extends any class or not. You see, so this class is not extending any other class. So if the compiler finds that this class is not, it's not extending any other class, so simply it adds extends object. Simply it adds extends object here. Yes. Okay. So if the compiler, whenever it compiles the class, it will check whether that class is extending any other class or not. If that class is not extending any other class, then simply it adds extends object here. That's it. Okay. So first suppose, what if a class is already extending another class? You see, for example, if you consider contract employee, it already extends object class, right? The compiler still it adds extends object. Can I say that the contract employee class extends object class? What do people think? No. In this case, actually the compiler will not add extends object here, because a class, that it cannot extend more than one class. Okay, it cannot extend more than one class. Okay, but in this case, you see, the employee class, the superclass, it's not extending any other class, right? So this class, the compiler will make it extends object. That means now the contract employee class, you see, it inherits that object class through the object class here now. It inherits the object class through the employee class. So this is multi-level inheritance. So now for the contract employee class, object class is an indirect parent. Yes. whereas employee is a direct parent here. Yes. Okay. But now the question is, why Java is making sure that all the classes extend object class? Why every class has to extend object class? Yes. Anyone got answer for this question? Okay. So I'll tell you people why Java, see, it makes every class a subclass of object class, or why it makes every class to extend object class. Directly or indirectly, all the classes, they are subclasses of object class, I can say. Yes. You know, the answer for this question is, in the object class, you got methods, and that methods, they represent the most common operations which we perform on the objects. The most common operations, okay, so which we perform on the objects, basically, they are represented by the methods. So now Java wants to make sure that all the classes they inherit that methods which represent the common operations which we perform on the objects. Yes. So let me show you that methods once. Okay. Let's go through the methods. Just a minute, please. You see, this is your object class and the methods of the object class. You can just read the methods here. You see they are get class, hash code, equals, clone, to string, notify, notify all, wait, it is overloaded 3 times, and finalize. Just read once. You should be familiar with these methods. Just give a reading here once. Yes. Yes. Now I want you people to just check this because you should be always familiar. You know, now we're going to dig into the details here of this object class methods. As a Java developer, you are supposed to know all these methods. You should be familiar with this methods, I can say. Okay, you're supposed to be familiar with this methods. Now let's start. Now first, suppose you consider any class. Let's say you'll take this product objects. Let's say we got two product objects. Can I say we got two product objects here? Are we creating two product objects? Yes. What do you people think? So the variables are same, the input data is same. Okay. So yes, that's right. Exactly. Very good. So the objects are different, of course. Okay. So we got two different objects here, but the only thing is they both got the same content. Okay. Now you got two reference variables here. You see, product one is one reference variable, product two is another reference variable here. Yes. So each reference variable, it holds a reference to an object. Now, how do we know these two reference variables are referring to two different objects? Okay, that is where actually not equals method. If you want to see whether two reference variables are referring to same object or not, we use relational operator here. Okay, this one. So product one equal to product two. You see, now what this relational operator does, double equal to this relational operator, it will check whether these two reference variables, product 1 and product 2, they're referring to the same object or a different one. You know, the relational operator, what it does is, if these two reference variables are referring to the same object, it returns true. Otherwise, it returns false. So now what do people think? Should it return true or false? Are they referring to the same object or different object? So what it is supposed to do now? So the statement, when I execute it, the relational operator, will it return true or false?
False.
So it has to return false. Yes, it has to return false because these two reference variables are referring to two different objects, not same object. Though the data is same, the content is same, but the objects are different. Okay, fine. So I want you people to understand one thing. So the relational operator double equal to, it is not checking for the content in the objects. It is only checking whether these two reference variables are referring to the same object or a different object here. Yes, that's it. Okay. Hope you people got it. But what if I want to compare the contents of the objects? What if you want to compare the contents in that object now? What to do? Yes, this is where the object class method equals to comes into the picture. Okay, we got a method, you see, one of the methods here in the object class equals. Okay, but before we talk about equals method, I would like to show you people one more example. So most of you people do this mistake if you're new to Java. Yes, for suppose here I got, sorry, just a second. I got two string objects. Say something like this. Good morning. Now, for suppose here, if I do this s1 double equal to s2. Now this statement, what it returns, true or false?
false.
So it should be false. Okay. So what about others? Actually, it returns false itself. Okay, it returns false. Yes. You see, it returns false. So the relational operator, I want you people to understand that it always checks the references, not the content and the objects. Yes. Okay. So now if you want to compare the contents of the objects, okay, you should use equals method defined in the object class. Use this equals method this way. You see, this equals method defined in the object class, how will you use it? So if you got two objects to compare, so use one of the object references to call the equals method, and the other object reference you have to pass it explicitly here. Okay. Now the equals method, you see, it will take both the, you see we are using one of the object reference to call it, and you see S1 we are using it to call the method, S2 you are passing the reference here. Yes. So now it will compare the contents of these two objects, and if the content is same, it returns true. Otherwise, it returns false. See, it returns true. Fine. Now, can we use this equals method for the product objects also? Let's see. Now we'll use that equals method to compare the contents of the product objects this way. Okay. So I'm using one of the product object reference to call the equals method, and the other object reference will pass it to the equals method explicitly. You're passing into the equals method explicitly. Yes. Okay. Now, what do you people think? Will it return true or false?
True.
You know, this time actually still it returns false. Still it returns false. I'll show you people. You see, it returns false. Though the object's content is same, but it returns false. Why so? Here you need to know something about equals method. Okay, don't panic. Though it returns false, we'll set it right. Don't worry. Yes. You'll find that the equals method in the object class, the equals method of the object class, the functionality of the equals method of the object class is same as double equal to operator. The functionality of the equals method of the object class is same as double equal to operator. Yes. Okay. The functionality of the equals method of the object class, the functionality of the equals method in the object class, it is same as double equal to operator. But in the string class, you see, it also inherits that object class method. Why it is comparing the contents? Why it is comparing the contents of that object? Because the string class, what it is doing is, it is overriding that superclass method, object class method, such a way that it compares the contents of the objects, string objects. Okay, you'll find that the string class is overriding the object class equals method, superclass equals method, such a way that it compares the contents of the objects here. That's the reason why in the string class equals method was comparing the contents of the objects. But you see, in the product class, we are we are just inheriting that object class equals method whose functionality is still intact, which it is inherited from the superclass, from the object class. What is it? It is same as double equal to operator. Now, if you want the equals method of the object class to compare the contents, then we have to override that equals method in the product class now. We have to override the equals method in the product class. By default, the functionality to compare the contents of the object is not defined in the object class. By default, it is actually not defined in the object class. Okay. So every class here,
Mahesh,
subclass,
can you?
it has to just please don't interrupt in between. Just stop for a while. So every class, subclass which inherits that object class, you see, which inherits that equals method, it has to override that equals method and it has to write the code to compare the contents of that object. Even string class does the same. String class is basically overriding the equals method of the object class such a way that it compares the contents of that string objects. So even product class has to do the same now. It should override that equals method of the object class to compare the contents of the product objects. Okay, so by default, that functionality to compare the contents of the objects is not defined in the object class. Yes, yeah. So, you know, it is better if you people wait for some time if you got any questions, because first of all, we'll see this. You know, no one will understand the concept completely until and unless you go through this example or practically if you see these things, then only people will understand. And don't think about too much. Just follow me for a while. Anyways, I'll ask you people if you got any doubts. uh, yes, at appropriate time I'll ask you people, I'll give you people a chance to ask doubts. Yeah, so now the question is we have to override the toString method. So let's try to do that. Sorry, override the equals method. You see, this is the equals method now which we are overriding it from the this is defined in the superclass. Now in the product class we are overriding. So now in this equals method you are supposed to write the code to compare the contents of the product objects. Now in order to compare the contents of the product objects you need those two product object references, right? So one of the object reference is used to call the equals method, right? So the object reference which is used to call the equals method, the object reference which is used to call the equals method, how can we read that object reference or access that object reference? What do you people think? How can we get that object reference here? This, if you people remember this, you see equals method, please remember that. Okay, if you can observe this equals method, you'll find that it's a non-static method. Now, if it is a non-static method, always you need an object reference to call that method, right? And we are doing it here. You see product one dot equals. And that object reference which you passed to call the equals method, that object reference is implicitly passed on to to this method here, and it is stored in this variable. Okay, that means product one object reference is stored in this variable, that current object reference. You see, the object reference which was used to call this method, that object reference is stored in this. Next, the other object reference is passed explicitly to the equals method. The other object reference is passed explicitly to the equals method. So that is stored in this parameter here, right? It is object type, superclass type. So what you can do is you can just store it back into subclass reference variable by casting it. We saw this earlier. That's it. Now we got both the object references here. We got both the object references. Yes. Here, now let's compare these two objects. Product1 dot id equal to product 2 dot id, and product 1 dot name is string type, right? Use equals method, product 2 dot name. For string objects, don't use double equal to operator, use equals method to compare the contents of the strings. Okay. Next, product price also. It's a float type, so I can use relational operator. Product 1 dot price equal to product 2 dot price, and product 1 dot description equals product 2 dot description. Here, so we have to compare the contents of both the objects, right, which is stored in that fields. So that's the reason why I have written this code here. Okay, so we are comparing all the fields of both the objects. You see, if all these conditions are true, then only I can say that product 1 is equal to product 2. In that case, this method returns true. Else, it returns false. That's it. Okay. Now, this time, if I use equals method, now the product class equals method will be called, which is overriding the object class equals method. Now, the product class equals method will compare the contents of the product objects, right? This time, you should see true here. Yes, it returns true. Okay. So, this is how we're going to compare the contents of the objects using equals method. Even the string class also overrides the equals method this way, and in that string class equals method, you got the logic to compare the contents of string objects. That's it. Okay, so now you people tell me if you got any questions in this regard. Yes. No. Okay. So yes, others, anyone got any questions? So I have couple of questions for you people. Why the object class equals method is not providing the functionality to compare the contents of the objects? Why we have to explicitly override that method here and write the logic to compare the contents of the objects? What do you people think? Yes. Why we need to do this explicitly? Why the object class is not providing that functionality here? Okay, that is what I'm saying. Like, why this object class is not providing the equals method of the object class? Why it is not providing that code or logic to compare the objects? That's right. You see, every object is different type. Now the string object is different from savings account object. Savings account object is different from employee object. You see that fields in these objects are going to be different. Now you see the fields which we saw in the savings account object are different from the fields which we saw in the employee object. And the fields of that employee object are different from the product object again. You see, you got different types of objects with different types of fields. Now, in order to compare them, yes, of course, we need separate logic itself, and that can be only written in that specific classes. You got it? Yes, that's right. Yes, hope this is clear for everyone. That's the reason why you see the responsibility of implementing that equals method, okay, overriding that equals method is actually left to the developers itself. Okay, yes, now we developers, we have to take care of it. So that class, it's also now the responsibility of the class to have that method. It should have that method. Of course, it inherits that method, right? Yes, from the object class. Fine. Now I have a question here. Second question. First question, hope this is clear for everyone. Now my second question is actually why we have to only use equals method particularly here to write the comparison logic to compare the contents of the object, why we have to explicitly override the equals method. Can't we define our own method for this purpose? Can't we define our own method here? Yes. You got the question? Why we have to use a equals method itself? Can't we define our own method to compare the contents of the objects? Why we have to use that equals method only? Yes. So hope everyone got the question here, right?
Could you repeat the question? I'm sorry.
Okay. So the question is why we have to use this equals method itself here explicitly. Uh, can't we define our own method to write the comparison logic to compare the contents of the objects? Can't we define our own method to compare the contents of the objects? Why we have to use equals method only? You got the question now? Of course, here also you're overriding it. Anyways, you have to add a new method itself again, right? Though it is existing, you're completely redefining it again, right? Don't you think this is a kind of restriction, like use only particular method? Is there any advantage for this? I can say yes, of course. You'll find that Java, it is trying to standardize objects are compared in the way the objects are compared through the equals method. Java is trying to standardize the way the objects are compared. Yes. You see, you'll find that through the equals method. Now, 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 in all the classes, everyone will use the same method here, right? So this method is now a standardized method. It's a common method which helps everyone to understand easily that okay, this method has got the comparison logic. Even it will be easy for you for the developers to define this method because it's the most common method. Now everyone will be familiar with it. We don't need to have a separate method and remember that method. Okay. Yes, you'll find that here all the classes, no matter if it's predefined or user defined, they will use the same equals method to compare the contents of the objects. Okay, they'll use the same equals method to compare the contents of the objects here. That's it. Okay, easy to implement, easy to remember. Now it is standardized. Is it clear? Yes. Any questions in this regard? Okay, good. So now there are other methods also in the object class, okay, which we have to go through. Now you see how the overriding concept is helping us. If you can just recollect the concept of overriding as I told you people. A subclass, you see, it can implement its own functionality by overriding the superclass method, right? Now, in this case, this product class, it overrides that product class method, sorry, equals method. Product class overrides equals method of the object class to compare the contents of that object. In order to compare the contents of that object, the method is overridden. Yes. So this way, every class can override the superclass methods to meet its own requirements here. Okay. In order to meet the requirements accordingly, they can override the methods. Yes, fine. Next, not all methods can be overridden from the object class. Can you tell me which methods we cannot override from the object class? Okay, I guess it is difficult to type in that names. You can just unmute and talk to me. Tell me which methods we cannot override from the object class.
The native methods that they have over there?
Uh, Not native.
All finals.
Yes. You know, all the methods which are declared as final, all the methods which are declared as final, like get class, notify, notify all, wait, wait and wait. The final methods, you see, when we declare a method as final, you'll find that we cannot override that method in the subclass. Now, the subclasses will be able to inherit this method, but they cannot override this method here. They cannot override this method. Yes. What are native methods? Any idea about this native methods? Few methods are declared as native. The native keyword, why it is used? Yeah, that is what I'm asking. What exactly the native methods are? Native methods means that indicates that the functionality of this method, it is not implemented in Java. The functionality of that method is implemented using native languages like C, C++. The functionality of that methods, it is not implemented using Java. It is actually implemented using native languages like C, C++. That is what it indicates. Okay. So, you know, in the starting days of Java, such methods have been defined because at that time C, C++ was very popular and there were so many developers who are very good at C, C++. At that time, few functionalities were implemented using such C, C++ languages. And that you see this native methods they got internally, they call that functions. Okay. Yes. That C, C++ functions are invoked here. Okay, fine. No, though we don't do that now. Yes. Okay. That is about native story of native. Native methods, it indicates that the functionality is not implemented in Java. Instead, it is implemented using native languages like C, C++. Yes. Okay. So we got other methods also here. We'll talk about them. We'll do it in the next session. Okay. Yeah. So I'll stop it here today. So let's do one thing. We'll meet on Monday at our regular time. So next Saturday, Sunday, next week, Saturday, Sunday, both days, I'll be taking the class for you people. But this week, so just a minute. Yeah, yeah. So next week and Saturday, Sunday, both the days we'll have classes. But this Sunday, I'm not going to take the class. Yeah. So again, we'll meet on Monday at the rate our regular time. Okay. Monday, we got a class at our regular time. Okay then. So I'll stop it here. Thank you all.